Okay, so this is going to be chapter 28, quiz 6 for my book, Overcoming Digital SAT Math. Remember, if you have a copy of this, make sure to attempt to do the problems on your own first and corrections on your own first before referencing this video for anything that you can't do on your own or can't correct on your own for the best results. So let's go ahead and start with number 1 right here. Whoops. And it says, an alternative rock band sold a lot of tickets to their various concerts over the years. The graph above shows the amount of tickets sold each year for a certain period of time. The tickets sold for 1977 is what fraction of the total tickets sold from 1975 to 1982. So let's first focus on 1977. So this says tickets sold in thousands, 1977. So that's going to line up with halfway between 10 and 15. So that's going to be 12.5. 12.5, if we think about that, well, technically you could do like 12.5 times 1,000, like that many thousands. We don't really need to like worry about the thousands, as I'll show you later, because it cancels out on top and bottom. So I'm not going to like fully do that out, but you're free to do that. And we're going to go to 1975 to 1982. So let's look at each of the years and how much they've sold. So again, I'm not going to do the times 1,000 thing because I'll show you later that it just cancels out anyway, so it's kind of like pointless. So this is going to be 10 times 1,000, 10,000. And then this is going to be 20. This one's going to be 5. This one's going to be 7.5. And this one's going to be 10. And this one's going to be 25, and this one is going to be lining up halfway between 20 and 25, so 22.5. Why does it keep doing that? Sorry, the live's being weird. Okay, so now what we have to do is we have to say, okay, we're talking about the 1977 tickets, so we're talking about 12.5, technically times 1,000, so I'll show you like the times 1,000 thing, over if we add all of these up and then times it by 1,000. So like 10 plus 20 plus 12.5 plus 5 plus 7.5, I'm running out of room, plus 10 plus 25 plus 22.5, all of that many thousands, so then it's times 1,000, which you could just cancel that out on top and bottom. That's why I said it doesn't really matter if you write it in thousands for this problem. So then what you're going to do is just plug that into a calculator, because remember, it's the digital SAT exam. And when you do 12.5 divided by all of that added up, you're going to get 0.1 repeating, which you would just write as 0.1111, because that's 5 characters for a positive answer, like they allow you to do on the digital SAT exam. So let's go to number 2. So for number 2, we have this inequality statement right here, and we need to know what can be true. Which of these can be true. So I'm going to see how can I manipulate this to, if possible, get these answers or that are listed next to the Roman numerals. So number 1 says we have x minus n is greater than or equal to 0. Someone just asked a question, will you be doing ACT lives anytime soon? I have a test coming up. I'm trying to get the digital SAT book done. That's why I'm doing digital SAT lives. But like this is a question that you could be asked on the ACT. So like this is going to help you with that as well. And actually, they aren't doing, it seems like, Roman numeral problems. I couldn't verify it off of the study guide that they released, but it looks like they're not even coming out with them, but I just included them just because, like, I think they're extra tricky, and, like, you might as well do stuff that's more challenging. But, like, the ACT definitely has these, so, like, if anything, this would be more ACT right now, and I just included it as, like, an extra challenge. So let's look at this. Let's try to see if we can manipulate it to turn it into x minus n is greater than or equal to 0. Well, let's see. I can subtract n from each side here. So if I subtract n right there, it's going to be 0 because n minus n is just 0. And then I could say, oh, well, then I could subtract n there. And then I do have exactly what number 1 is saying. So, like, I can manipulate it that way. That works. Now we have x minus 10 is less than or equal to 2n. So let's think, how can I manipulate this to look like that? Well, I could subtract 10 from each side. So I could say, okay, if I subtract 10, I'm going to get this. So that correlates or matches up. Now I'm going to say, okay, is there any way that I can manipulate this to get n is greater than or equal to negative 10? So let me see. Let's see. N is greater than, or yeah. So you have this side and this side right here. Like if even though x is in between, like you could still say that n is less than or equal to 2n plus 10. So you could say that n is less than or equal to 2n plus 10. So then if I subtract n from each side, I'm going to have 0 is less than or equal to n plus 10. And then I just have to subtract 10 from each side. And then I would get this, which is exactly what number 3 says, so that works as well. So 1, 2, and 3 works. So it's all about just like manipulating to see if you can make it look like one of the options. Oh, this one, I need to fix that. It should be like right on top right there, but it says for the function shown above, which of the following equivalent forms of f of x shows the maximum value of f as a constant or a coefficient? So we're referencing this one right here. So first thing I'm going to do is I'm going to FOIL this out so that I have, what do you call it? I have it looking more like what I'm used to quadratics looking like. So FOIL is an acronym that stands for what I'm going to multiply together. So F stands for I multiply the first things together. So x times x is x squared. O stands for I multiply the outer terms together. So negative 3 times x, negative 3x. I stands for I multiply the inner terms together. So 5 times x, 5x. And then L stands for last, multiply the last things together. So positive 5 times negative 3, which is going to be negative 15. Now I'm going to combine my like terms right here. And that's going to give me x squared plus 2x minus 15. Now, you want to be careful here because, yes, that is one of the answer choices, but you have to be careful. What is the question actually asking you? I would say like number one thing, especially if you're like a high performing student that like, and you're just like, why can't my score increase? It's because no matter what section it is, reading, now it's not called writing anymore, like what is it called writing anymore? I forget what the official term is, but basically like if you're doing reading, grammar on these test prep things, or math on ACT, SAT, usually it's that you're not paying attention to what the question is actually asking. Like you're giving them something that's true, like this is a true statement, but it's not what the question's actually asking. The question's actually asking which of these equivalent forms shows f of x of f of x shows the maximum value of f as a constant or coefficient. So we want one of these that shows the maximum value as a constant or coefficient. So I need to know what the maximum value is first before I determine which of these is correct. So I know that this is the same thing as that. And I know that to find the maximum value, I need to find the x max, which is equal to negative b over 2a. And then plug it into the function to find the y max. So let's start by finding the x max. So a is going to be the number being multiplied by x squared, so a is 1. B is the number multiplied by x, so b is 2. So then if I'm trying to find out what x max is, I would plug in negative 2 over 2 times 1. So that's going to be equal to negative 1. So my x max is negative 1. So to find the maximum value, all I have to do is plug in negative 1 for x. So it would be 1 times negative 1 squared plus 2 times negative 1 minus 15. So negative 1 squared is just positive 1. 1 times 1 is 1. 2 times negative 1, negative 2. And then just copy over the minus 15. 1 minus 2 is negative 1. Negative 1 minus 15 is negative 16. So our maximum value is negative 16. So that's why it can't be b. Even though that's like an equivalent form, it's not an equivalent form that shows the maximum value as a constant or a coefficient. I don't see negative 16 anywhere there, but I do see it in C and D. So now I just have to determine which one's correct, C or D. So remember, another thing we know about quadratics, usually you're used to hearing them about as parabolas when we're referencing this exact formula. is that we can write them in something called vertex form, which looks like this, where h comma k is going to be your vertex. So I know that k is my y max, or like my y value for the vertex. Those are all like different ways of saying it. So I know that negative 16 should be out here. That matches for both. The one that's different is what they're saying should be inside next to the x right there. So my h, or my x max value, is -1. I need to have minus -1 because I need to have minus h. So minus -1 would be plus 1. So it should be D. So let me just erase that. And then now let's go to the, and how is this relevant to my life? It's probably not, honestly. I'm not gonna lie to you. So then let's go to number 4. In the figure below, all necessary angles have been labeled. What is the value of C plus B? Write your answer without the degree symbol. Okay, so remember, you kind of have to like picture a circle. If you add up like all the angles that make up that circle, you're gonna get 360 degrees, because we learned a circle has 360 degrees. So let's write that as an equation. We're going to add everything up there. So 51 plus C plus B plus 74 is equal to 360 degrees. And then I just want to solve for what C plus B is. Why is my pen being weird? I'm solving for what C plus B is. So I'm going to combine my like terms of 51 plus 74. Thanks for the likes, guys. So that's 125. Plus C plus B is equal to 360, and then I need to subtract 125, so then I have C plus B is equal to, and then I'm just doing it off to the side, don't make fun of me, the numbers flip in my head. Okay, so then we're going to have 235 as our answer. So that's what C plus B is. I need tutoring on voting methods. I don't understand it, but my answers are right. Voting methods. What do you mean? Do you mean like the statistics stuff? Like the survey stuff? Anyway, let's go to number 5. So we have this quadratic right here, and we want to find the sum of solutions. Remember, sum of solutions, that's just this formula, negative b over a, and you determine what b and a are once you set the quadratic equal to 0, which this problem's nice for you and just already has it set equal to 0, so you can go ahead and nicely label what a, b, and c are. But we only need a and b here. So a is going to be the number times x squared, b is going to be the number times x. So now let's plug that into the sum of solutions formula. And when we do that, we get negative 4 over 8, or negative 1/2. So it's going to be D. Thank you guys for the likes. Please like and share this with people so that we can get it out to as many people as possible. And let's go to... Sorry. Someone's comment just cracked me up. Okay, the graph of g of x, of y equals g of x minus 2 is given below. Which of the following equations could represent the function g? So this is g of x when it's been translated down by 2, because that's what like g of x minus 2 is. So to get back to the original g of x, we're going to say, let's put it back up 2. So it's going to go up by 2 to find g of x. So let's think, okay, here's a point that's very clearly like, we could figure out what that point is. It's easy. It's a perfect corner point. So each of these boxes is going up by 2, right? If I'm labeling this point, that means that I'm going to have 0, 2 as my x, y value for that point. So now what I can do is I'm going to say, okay, which of these matches, if I were to now go up by 2, that I'm going to get the point I should, basically. So this is 0, 2. If I go up by 2, I'm going to be at 0, 4. And then that's supposed to be a 0. So now I have to ask myself, okay, which of these fits that 0, 4 would be a point that's part of that function. So I'm going to plug in 0 for x, and I'm going to see if I get 4 for g of x. So let's do that. So if I plug in 0 right here for x, 5 to the 0, anything to the 0 power is 1. So that's going to be 1 plus 2, which is 3. That's not 4. And then for b, I'm going to plug in, again, 0 right there. 5 to the 0 power is equal to 1. That's not 4. Now over here, I'm going to plug in 0 for my x. So 5 to the 0 power is equal to 1 plus 3. That does equal 4. So that could work. So now let's try d. 5 to the 0 power is 1. Minus 1 is equal to 0. That is not 4. So it definitely is answer choice C. So now let's go and do number 7. What are all the solutions to the following equation right here? Now for this one, it would probably be easiest to just start plugging in. I've done other videos and I'll be uploading an absolute value chapter for people that want to see like every single step of like solving it. But for the digital SAT, like if they gave you this, I would just start plugging in because you're going to have to anyway to check your answer with absolute value problems. So let's start by doing the 3. So I'm going to plug in 3 where I see x. And I'm going to see, does this work, basically. So absolute value of 3 minus 9 is going to be negative 6. So I have the absolute value of negative 6, which just turns it into a positive 6. And it's saying that that has to equal negative 6 times 3. And that is true because you're going to get negative 18 here and negative 18 here. So 3 works. X equaling 3 works. But I can't just pick C. I have to also now see, okay, but another option is that it could be negative 9. So let me check if negative 9 works. So everywhere I see an X, I'm going to plug in a negative 9, and then I'm going to see, okay, does that work? Does that give me a true statement? So I'm plugging in negative 9 everywhere I see an X. Negative 9 minus negative 9 is negative 18, so I have the absolute value of negative 18, which just turns it to positive 18. So I'm going to have negative 3 times 18 is equal to, and then this is going to be negative 6 times negative 9. Technically, you already know like negative times a negative is a positive, so it definitely can't be equal. Like this is definitely not going to work, but I'll just show you. This has to equal positive 54. This is going to be equaling negative 54. Negative 54 does not equal a positive 54. Therefore, negative 9 cannot work for x, so it is in fact only C, x equaling 3. So that was that's number 7. So now we're on number 8. Please like and share this live with people so we can get it out to more people. And thank you for everyone who's already liking it. So let's go to number 8. So we have this system of equations and we want to find what is the value of x. So here the easiest option, because you can solve with substitution, elimination, or like graphing. Just looking at this, I see my easiest way to solve the system would be to just do elimination, adding these up, because if I just add these up, I can cancel these two values out because negative 6y plus 6y cancels out to 0. So I'm going to add up everything and I get 6x is equal to 75. Then I'm going to divide by 6 on each side. And I'm going to get x is equal to 75 over 6. Now, what I recommend you do on the digital SAT is on these fill-in questions, try to just do it as a decimal. So like when you do 75 divided by 6, you're going to get 12.5. But if you're dead set on making it into a fraction and like writing it as a fraction, you just have to make sure you simplify this. So the way that you would simplify this is saying, okay, what's the greatest number that goes into both the top and the bottom? And that would be 3. So then you should get 25 over, 25 over 2 as your answer right there. Remember, you can't do mixed numbers, so don't turn this into a mixed number. So let's go to number 9. The graph of a quadratic function has a vertex right here. If one of the x-intercepts is at this, then what is the other x-intercept? So remember that the x value for the vertex for a parabola, quadratic function, same thing, is the vertex is going to be halfway between the x-intercepts. So you basically have a midpoint formula that you're using here. So to find the, this is the midpoint, like -4 is the middle value between the two x-intercepts. So midpoint formula says that the midpoint, which in this case is -4, is equal to, if you add up the two endpoint values and then divide by 2. So one of my x-intercepts, one of my endpoint values is going to be -11/5. And then I have this mystery other x-intercept I'm solving for, which I'm just going to put x in for that. And then I need to divide by 2. So now I'm just going to solve for x. So multiply each side by 2. That's going to give me -8 is equal to -11/5 plus x. Then I'm going to add 11/5 to each side. So then I have -8 over 1 plus 11/5 is equal to x. Now I need to have a common denominator, so I'm going to multiply by 5 on top and bottom. That's going to give me -40 over 5 plus 11/5 is equal to x. So then I'm going to get -29 over 5. Yeah, I did that right. -29 over 5, so then that's going to be D. I question my calculation skills as it gets later at night. So now let's go to number 10. How many solutions are there for the system of equations shown above? Okay, so it's nice and easy, like set up already where y is isolated for each of these. So they're saying that this is our system right here. And basically, if we're going to set this up, kind of like it's substitution in a way. People are used to like thinking of it as like, what is it called? Point of intersection or whatever, like where you set the y's equal to each other, but it's substitution with systems. Like I'm saying the y right here can also equal this if this is a systems of equations. Like I can plug in 6x plus 3 for that y value right there. So that's what I'm going to do. I'm going to say 6x plus 3 has to equal 6x plus 5. Well, just looking at that, you know that's never going to happen. Like you can't have, like let's say x is equal to 1. 6 times 1 plus 3, that's going to be 9. If it's equal to 1 over here, x is equal to 1 right here, it's going to be 6 times 1 plus 5, that's 11. Like you have the same, you're always going to get the same exact number right here for plugging in the same exact x, but then you're either going to add 3 or add 5. That's never going to be equal to each other. That's never going to work. That's impossible. So there's 0 solutions. Okay, so let's go to number 11. Which equation has the same solution as the following equation? So I'm going to look at the answer choices to kind of help me out and see what might have happened. So right away, I'm seeing that, like I don't see an 100 there, so I know that they probably divided like that out maybe, or like possibly divided by 10 because I see like a 10x there. So I'm going to try dividing by 10. So I'm going to get rid of a 0 here and a 0 here. And then now I'm going to say, okay, I have 10 times x plus 240 is equal to 32. And then I'm going to say, okay, now I'm going to do distributive property to make it look more like one of these. So then 10 times x is going to be 10x. And then 240 times 10 is going to be 2,400. And that's going to be equal to 32. So then the answer is going to be A. So let's go to number 12 now. So for number 12, it says this is going to be equivalent to this. And then we want to find the value of b over a. So this is what we're solving for, b over a. So my goal is to make this look more like this format. That way I can easily determine what is a and b and plug it in to find the value of b over a. So I'm going to ask myself, how can I do that? Well, I can kind of like distribute out or factor out. That's the word. I'm going to factor out the 4 over 16. And then I'm going to say that I have the x to the 6th over x to the 5th still right over there. So this is basically like the precursor to that one, because if I just multiply this, I get back to that original expression. They're the same thing. I'm just manipulating it to look more like this to help me out. So now I can say, okay, 4 over 16, that's the same thing if I simplify it by dividing by 4 on top and bottom. That's the same thing as 1/4. And then I can use the quotient rule right here to say, okay, that's going to be x to the first power, because I do 6 minus 5 is 1, which we don't typically write to the first power. I'm just writing it as a visual to help me out because it looks more like this when I do that. So now I can easily see, okay, what's being multiplied by that x to some power? Well, the thing being multiplied by it is 1/4, so that should match up with a. A is equaling 1/4. And then what's going to be the exponent right here, because that's going to be b, well, b has to equal 1 then. So now I know what a and b are, so I can plug it into b to find what b over a is. So that would be 1 over 1/4, which equals 4. So that would be your answer for 12. Thank you guys for sharing the live. Please like and share the live so we can get this out to more people. And it really helps me out if you care about that. So let's keep on going. So this one's going to be, okay, so we have an exponential situation right here. The function f gives the predicted strength of a professional weightlifter based on the number of years t the weightlifter has been in training. What does f of 0 represent? You just saved me with that answer for 12. Thank you so much. Happy to help. So what does f of 0 represent? Okay, so remember they told us that t is going to be the number of years that they've been training. So if t is 0, that means they've been training for 0 years. So let's see if there's anything that kind of corresponds with that. So the predicted strength of the professional weightlifter when they began training for the first time. So if they're training for the first time, it's been 0 years that they've been training. So that matches. The time when the professional weightlifter has 0 predicted strength. So that is incorrect, because that would have to mean that like the whole entire function equals 0, not that just t is equal to 0. So that's why that one's wrong. And then the maximum predicted strength for the weightlifter, no, that's just like totally off. And then the predicted strength of the professional weightlifter after a single training session, no, because that, remember, 0 means like they've never been training, or they haven't been training for any years. Like this is the first time they're training. So that doesn't correlate with what was stated in the problem. So it's going to have to be A. So f of 0 is basically like this 0 part helps you kind of eliminate answers, and then you kind of have to think of the whole thing, f of 0, like interpret the whole thing to get the correct answer choice, which is like it's the predicted strength when you've had like no training, like you're training for the first time. So then let's go to number 14. So number 14, we have this data set above. The data above represents Ava's math test scores for the entire first semester. If Ava received a 98 instead of her 67 test score, so 98 instead of 67, then which of the following would not change? So we want something that's not going to change. So let's start with the easy ones. Mode is the one that occurs most frequently. So before we got rid of the 67, like when 67 was there, let's see what was the mode. Mode is the one that occurs most frequently in the list. I don't think anything was repeated even. So there was no mode there. And there's still no mode afterwards. If you replace 67 with 98, there's still no number that's repeating more than once. So there's no mode. So no mode to no mode. So that means there's no change. So it definitely has to include that one, but be careful because answer choice D says it could be B and C. So let's now check if it's C. The range. So the original range, which I'll call the OG range. Remember, range is the high minus the low. So when we had 67, that was the low. So I'm going to subtract 67 from the high, the initial high, which was going to be 99. So then that would be 32. Now the new range, when 67 is replaced with 98, well, we're going to have the same high value, 99, and then minus, let's see, what would be the low when we replace that? The low would be 76. So then, I mean, you can tell already that it's going to be like not the same value, but it's going to be 23, which we're looking for something that does not change. That definitely changes, like it's not the same number. So it can't be that one, it can't be that one, so it has to be B. Okay, so let's go to the next one, number 15. Is everything okay? What? Okay, number 15, yeah. Number 15, if line A is defined by the equation this, and line B is parallel to line A, what is the slope of line B? Okay, so this is the equation for line A. I'm going to isolate y so that I have the equation written in the format of y equals mx plus b, so I can easily determine what my slope is. So I'm going to subtract 15x from each side. So then I'm going to have 6 minus 15x is equal to negative 3y. Now I'm going to divide by negative 3 on each side to completely isolate y. So 6 divided by negative 3 is negative 2. Negative 15x divided by negative 3 is going to be 5x. And that's going to equal y. So now you see it looks more like the format we're used to. So the number that's being multiplied by x is our slope. So 5 is our slope for line A. And if line B is parallel, it's going to have the same slope. So that slope should be 5. Okay, so now that was quiz number 6. So let me go to quiz number 7. Let me check what page. It's $255. Okay. Okay, so now let's go to quiz number 7. What is one possible solution for this equation? So I see denominators. I don't feel like working with fractions, so I'm going to do the little shortcut where you can just multiply by the denominators. So I'm going to multiply by x minus 3. Thank you for the rows. And then we're going to now multiply that times each of the terms right here. So then it's going to cancel out with this x minus 3 to just give me 15. And then for the minus 3 over x minus 3, the x minus 3's cancel out. So I'm just left with wait. Something's wrong. Oh, wait. I'm so sorry. I got distracted. That is minus 3, yeah. And then 1 times x minus 3 is x minus 3. So then now I'm going to say 15 minus 3 is going to be 12, and that's going to equal x minus 3. So then I'm going to add 3 to each side, and that's going to give me x is equal to 15. Okay, so now let's go to this one right here. Thank you guys for the likes and shares and roses and everything. So let's go to this one. It says the equation above can be used to model the price P in dollars of a product after Q coupons are used. Based on the model, which of the following is the best interpretation of the number 5 in the equation? So basically we're trying to figure out what this guy means right here. Now, the easiest way for to do these interpretation problems is to think in units, especially when it's like, you know that this is a slope. This is the slope, like -5 is the slope, because this is just a linear equation. This is in y equals mx plus b format. It's just that your x is a q and your y is a p, but it's the same thing. So -5 is your slope. And if we're thinking about slope, slope is the change in y over the change in x, or in this case, the change in p, because p is representing your y, over the change in Q because Q is representing your X. So let's think of those units. So P is the price of a product. So it's the price in dollars of the product over, and then let's think of the units for Q. So Q is the number of coupons. So number of coupons on bottom. So it's like the change in price for the change in the number of coupons. So we have to keep that in mind. So let's read the answer choices. So the price of the product decreases by $5 with every coupon used. So remember, we said the slope is equal to -5, which is the same thing as -5 over 1. So it's saying it decreases in price by $5 for every 1 coupon used. That matches up perfectly, so it's A. So let's go and let me just erase this so it doesn't cover the next problem. And let's go to number 3. So if the side lengths of a right triangle are b plus 7, and b minus 6, then which equation can be used to solve for b? Okay, so let's draw this right triangle. And then let's label the sides now. So remember, the hypotenuse is the largest side, the longest side. So that has to be represented by b plus 7, because out of all of these options, the one that's the largest is going to be b plus 7. And it doesn't matter where you put the other two, like b can go here, b minus 6, or it could be like the opposite, doesn't matter, because what we're going to do is use Pythagorean theorem now to set up an equation. So Pythagorean theorem says you're going to square and add the each of the legs, and it's going to equal the hypotenuse squared. So I'm going to have b squared plus b minus 6 squared is equal to b plus 7 squared. So if I think about b minus 6 squared, that's the same thing as saying b minus 6 times b minus 6. And if I think of b plus 7 squared, that's the same thing as saying b plus 7 times b plus 7. And then I'm going to say b squared plus b squared. I'm foiling this out now. Sorry, I forgot to say that. I kind of just started doing it. So I'm foiling out this portion right here because I have 2 terms plus or minus in parentheses times 2 terms plus or minus in parentheses. So F stands for I multiply the first thing, so b times b is b squared. O stands for I multiply the outer thing, so -6 times b is -6b. I stands for I multiply the inner thing, so -6 times b is -6b. L stands for I multiply the last thing, so -6 times -6 is plus 36. And now I'm going to FOIL this as well on the right-hand side. Woo-woo. What happened? Okay. On the right-hand side, so I'm going to multiply the first terms, b times b is b squared. Outer term 7 times b is 7b. Inner term 7 times b is 7b. Last terms 7 times 7, so that's going to be 49. Now I'm going to combine my like terms. So I see I have like terms right here of b squared and b squared, so that's going to be 2b squared. And then I have like terms right here, -6b minus 6b is -12b. And then that's going to be plus 36 is equal to b squared plus, I have like terms right here of 7b plus 7b is 14b plus 49. So let's see if anything's matching up so far. Hold on. Oh yeah, I can see them all. Okay, so 2b, yeah, it matches D. So it'd be answer choice D right there. Let me just write a note to myself really quick of something I just remembered. Okay, so let's go to number 4 now. So we're using this figure for, for questions 4 through 10. Thank you guys for the likes. Please like and share so that we can get this out to as many people as possible. So this is our triangle, and we want to find what the sine of H is. So remember SOHCAHTOA. that little acronym that tells you what sine, cosine, and tangent are equal to. So we're talking about the SO in SOHCAHTOA. So sine is equal to opposite over hypotenuse. Now let's look over here to figure out what the side lengths are. So it's a right triangle, and let's see, each of the squares is representing 2. So this is going 2, 4, 6, 2, 4, 6, and then a 1, because half of 2 is 1. So then that's going to be 7. And this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so this is one of the Pythagorean triples, a 7, 24, 25 right triangle. You could also use Pythagorean theorem if you don't have that memorized to figure out that this side is 25. So now what I'm going to do is, if I'm finding sine of h, h is my reference angle right here. So I have to think what's opposite of it. That would be 7. And then what's the hypotenuse? That would be 25. Ooh, that's supposed to be 25. So that's the answer there. Now I have to find cosine of f. So cosine is equal to adjacent over hypotenuse. So if I'm looking at angle f as my reference angle, the cosine would be the adjacent side, which is 7, over the hypotenuse, which is 25. So 7 over 25 for that one. Now I'm going to find the tangent of h. So tangent of h, tangent is the TOA part, so it would be the opposite over the adjacent. So if I'm looking at angle h, the opposite would be 7 and the adjacent would be 24. So it would be 7 over 24. Now I have secant of h. So secant is just going to be 1 over the cosine of h. So if I want to do 1 over the cosine of h, basically I'm just taking the reciprocal of whatever cosine of h is, which we didn't find cosine of h yet. So I'm going to start by finding cosine of h, and then I'm going to take the reciprocal to get secant of h. So cosine of h, remember that's the ca part, so it's adjacent over hypotenuse. So if I'm looking at h, it would be the adjacent 24. Oops, that looks like a 9. That's supposed to be a 24. Over the hypotenuse, which is 25. And then secant of h is just the reciprocal, or the flip version of that. So it's going to be 25 over 24. And then now let's find the cosecant of h. So cosecant is going to be 1 over the sine of h. So I have to find sine of h, which I already found was 7 over 25, and just take the reciprocal. So flip it to be 25 over 7. Now I'm going to find the cotangent of h, which is just going to be the reciprocal of tangent of h, like 1 over tan h. So did we find tan h? I forget. Yeah, we did. So tan h is 7 over 24, so the reciprocal would be 24 over 7 for that one. And then now we're going to do number 10, which is asking about the sine of 90 minus h. So hold on, which one's that? So sine of 90 minus h. So this is h, right? So remember, a triangle adds up to 180 degrees. So if this is already 90 and this is h, one way that we could label angle f is 90 minus h, because angle f plus angle h have to add up to 90 in order for the angles in the triangle to equal 180 degrees. So f is equal to 90 minus h. So if I'm trying to find the sine, I'm basically trying to find the sine of f. So you can go ahead and do that, or you can think about the trig identity that says the sine of one complementary angle equals the cosine of another. It's probably easiest for most people to just do like sine of f. So sine of f, opposite over the hypotenuse, so then it's going to be 24 over 25. So that's your answer here. Thank you guys for liking and sharing the live. Please continue to do so. Really helps out. So let's go to number 11 now. So for number 11, we have this, what's it called, like figure up here. For the figure above, all the labeled angles are in degrees, lines A, B, and C are parallel, and we're trying to find the value of this right here. So we need to determine what X and Y are before we can find the value of this. So let's do that. Well, if these are all parallel lines, remember with parallel lines, corresponding angles are equal. So if we're thinking about this, let me highlight it one at a time so we can focus on one transversal at a time. So if I'm focusing on this transversal, right, then 55 is the top right angle, and so is X for its respective line C. So X is also the top right angle, so those are corresponding angles. So X should equal 55. So X equals 55. Now I want to determine, okay, what is Y? So in order to determine what is Y, it's probably easiest to focus on this transversal. This is the transversal line right here. Because if I think corresponding angles, I can think, okay, well, the bottom, bottom right angle right here is 70. So that means that this angle has to be 70 as well, because it's the bottom right angle for its line C. And I know that Y plus 70 has to equal 180 because they add up to a straight line. So that means that Y has to be equal to 110 degrees. So now I can plug that in to find out what this is equal to. So I could say my X is 55, my Y is 110. So I'm just plugging that in there. And then some people will like think, oh, I'm just going to start multiplying this out. But remember, when you're simplifying radicals, you're going to have to factor them anyway. So it's kind of like there's no point in multiplying this out because you're just going to have to split it up into factors. So just keep splitting it up into more factors instead. So 55 is the same thing as 5 times 11. And then now I'm going to split 110 up into factors. That's the same thing as 55 times 2. And it's going to be over 110. Now 55 can be split up into 5 times 11. So now I have 5 times 11 times 5 times 11 times 2. So I see a pair of factors I could take out there, as well as a pair of factors I could take out here. So I could take out the 5 and the 11, multiply them to get 55. So now I have 55 root 2, because I have to keep the root 2 in there, over 110. Divide by the greatest common factor of 55. You get 1 times root 2, which is just root 2 on top. And then if I divide by 55 on the bottom, I'm going to get 2. So it's going to be root 2 over 2a. Okay, so now let's go to number 12 right here. So for number 12, this expression right here being squared, remember you can't just like people think of power to a power rule and they're just like, oh, it's just x to the 4th squared and minus y to the y over 3 squared. You can't do that, because what this really means is that you have x over 4 minus y over 3 times itself, that you really have this. And we know that when we have 2 terms plus or minus in parentheses times 2 terms plus or minus in parentheses, we have to do something called foiling. We have to FOIL, which is an acronym that stands for what we're multiplying. F is for first, so we have to multiply the first things. X over 4 times x over 4, which is going to be x squared over 16. O stands for multiply the outer, so x over 4 times negative y over 3. So that's going to be minus xy over 12. I stands for multiply the inner, so negative y over 3 times x over 4. So that's going to be negative xy over 12. L stands for last, so negative y over 3 times negative y over 3. So it's going to be plus y squared over 9. So now I'm going to combine my like terms here and copy everything else down. So I'm going to have minus 2xy when I combine those over 12 plus y squared over 9. And I'm going to simplify this. So I'm going to say 2 goes into 2 one time. So then I just have negative xy, and 2 goes into 12 6 times. So I should really have x squared over 16 minus xy over 6 plus y squared over 9. So that's just going to be answer choice B right there. Okay, let me just get rid of this mess so it doesn't carry over into our other problems. Can you show another question that's similar? So I'm trying to get these done because like I have to do it in order for like how the book is set up because these videos correspond to the book. But I did do a similar one, I believe, earlier. I think it was like my quiz 2 or quiz 3 video, which is up on YouTube already. Okay, so let's go to the next one, and there might be one later also because I'm gonna try to do a couple more quizzes. So let's go to number 13. We have this, and we want to basically represent m in terms of the other variables. So we want to isolate m, get m by itself. So we have to move things away from m. So I'm going to start by adding 2y to each side. So then that's going to give me mx is equal to kxy plus 2y. And then I want to get m by itself, so I have to divide by x. So then that's going to give me m is equal to kxy plus 2y over x. So then that's just answer choice B right there. Oops. Close that up. And then let's go to number 14. What does it mean? It's just it's not like a specific equation for like something in real life. It's just a test question. So let's go to number 14, which says each time x increases by 1, the value of y decreases by 4. When y is equal to 7, x is equal to 0, which of the following equations best represents this relationship? So we have a linear relationship. So y equals mx plus b, and it's telling you how x changes in relation to y, so that's telling you information that can help you with m, slope. Remember, slope, or m, is the change in y over the change in x. So it's saying each time x increases by 1, so as x changes by 1, goes up by 1, the value of y decreases by 4, so y goes down by 4, so the slope is negative 4. So that's going to be what I plug in there for m. And then we were also given y, a value for y that corresponds to another value for x, so we could plug that in here to find b, because remember, to have a linear equation, you have to plug in a number for m and for b to have your equation. So I'm going to say, okay, 7 is my y, negative 4 is my m, my slope, 0 is my x, plus b, so now I have 7 is equal to b, because negative 4 times 0 is just 0. So now I can plug in 7 for b, so it should just be y is equal to negative 4x plus 7, so that's just going to be answer choice A. So let's go to number 15 now. If g is equal, if g is a polynomial function, y is I can't read. Y is equal to g of x, and g of x has x-intercepts of this, basically, then which of the following is true? So those are the x-intercepts. Okay, so it's just rewriting it in a different way, and we have to see like which of these ways corresponds to the information we've been given. So they gave us some points. So remember, like g of x is, visualize it as like your y. So like when they're saying g of 0, they're saying like this is my negative 6 is my y when my x is 0. So this basically, if we wrote it as a point, would be 0 comma negative 6. Like the part inside the parentheses is your x, and like what the whole function equals is your y. So let's rewrite this, each of these as points to make it easier. Thank you guys for the likes. And so let's rewrite each of these. That would be negative 8 comma 8, negative 8 comma 0. So let's see, do any of these match the points we've been given? Yes, D does, so it has to be D. You're correct, whoever said that. So that's 15, so let's now go to 16. So we have this data above, and we want to find mean, median, mode, and range. So let's start by putting the list in order from least to greatest. You are free to do it from greatest to least if you want. I just always do least to greatest. So I'm going to reorder it, and then that's going to be 3. And then I'm going to have 3 different 4s I have to do. And then it's going to be 2 different 6s. And then it's going to be 2 different 8s. Oops. And then it's going to be a 9. So that's in order from least to greatest. So now I can easily find out what the median is. So let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So the middle points are right here with 4 and 6. Now, if I have 2 middle points, I have to find the average of them by adding them up and dividing by 2 to get the median. So that means that my median is going to be equal to 10 over 2, which is the same thing as 5. So median is equal to 5. Now, my mode is going to be the number that shows up the most frequently in my list. The number that pops up the most amount of times, the most frequently in my list is 4. So that's going to be my mode. The range is going to be the high minus the low value, like the highest minus low, so 9 minus 2, which is 7. And then mean is going to be, basically you add up all these values and then you divide by how many. So mean is equal to, you would just do, you could do 2 plus 3, like you could add them all up, but like a quicker way for most people, I'm going to just show you another way to do it, would be to use multiplication to your advantage. So like you have 3 groups of 4, so that's the same thing as 4 times 3, plus you have 2 groups of 6, so 2 times 6, plus you have 2 groups of 8, so that's 2 times 8, plus 9, and then divide by how many data points you have. So you have 10 data points in total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have to divide by 10 data points. So you would just plug that into your calculator, and when you do that, you should get 5.4 is your median, or not median, mean. Thank you guys for sharing and liking the live. Let's go to the next one. So we have box plots here. So this is dataset A's box plot. This is dataset B's box plot. For the box plot shown above, which of the following could be true? So let's go through them one at a time. The median of dataset B is between 2 and 3. So the median when we're looking at a box plot is the little line inside of the box. So like this is the median for dataset A, this is the median for dataset B. So the median is right there, which looks like it's halfway between 0 and 5. So it looks like it's at 2.5. So that correlates. Let's go to the other ones just to make sure it's not any of the other ones. The maximum of dataset A is 5. So the maximum is going to be like the end of the little tail part over here, like where it ends. That's like way past 5, so it's definitely not 5 for the max. Let me just erase that now, so it can't be B. The minimum's the opposite, it's the one on the left. So the minimum for dataset A, they're saying is 1. So the minimum would be right here for dataset A, and that's going to be only like a little bit before 2.5, so that's definitely not going to be 1. And then D, dataset B is either negatively or positively skewed. So dataset B right here is not skewed at all, like negatively or positively, because you'll see it's like the same size on for the boxes on each side. So it's not that one. So then it's going to be for sure A. I have trouble with problems that say like at least 8 people. I don't know what kind of problem that is. I'm going to need more specifics. So let's go to this one right now. So we have the graph shown above represents the mass Y in nanograms of uranium-238, U-238, remaining in a sample after X half-lives. If the half-life of U-238 is 4.5 billion years, then what is the mass in nanograms of U-238 remaining in the sample after 9 billion years? Okay, so this is the mass remaining right here, number of half-lives. Okay, so 9 billion years means it's going through 2 half-lives, because it's saying that 1 half-life is 4.5 billion years. 4.5 times 2 is 9 billion years. So that means that we have 2 half-lives happening. Or half-lives. Half-lives? Yeah, I think. Okay. We're not going to get too in depth into that. Okay. So we have 2 half-lives happening. So if we want to figure out what the mass is after those 2 half-lives, and we know that at 0 half-lives, it's at this value right here, which is going to be 3 nanograms, then that means we start out with 3, and then we multiply by a half 2 times since there's 2 half-lives. And that'll give us what the mass is in nanograms of U-238 remaining in the sample after 9 billion years. So it's just going to be 3 times 1/2 is just 1/4. So that's going to be 3/4 or 0.75. So B. And let's keep going to number 19 now. So for number 19, we have the system of equations, and we want to know how many solutions there are. So right away, like, you can easily tell if there's zero solutions or infinitely many if you start making them look as similar as possible to each other. So that's what I'm going to start out by doing. So I'm going to cross this out so we don't confuse it as being part of the problem. So I'm going to ask myself, is there any way I can manipulate one or more of these equations so that they look as similar as possible to each other? So let me see. I could multiply by 12. If I multiply by 12, like 5, 6 times 12, the 6 cancels out to 1, the 12 would cancel out to 2, so then it's 2 times 5, which is 10, so it would start looking more like the bottom. And then I'm going to do 1/4 x times 12, that's just going to be 3x. And then negative 1/6y times 12 is going to be negative 2y. So it's looking more like this bottom one, but not exactly like it yet. So I'm going to see if there's any way I can manipulate this to look more like that one, and I can subtract 3x from each side, so then I have 10 minus 3x is equal to negative 2y. So I have exactly the same thing. So I have the same exact line 2 different times as part of my system of equations. So that means they're going to be, if I think about how I would graph that, it would be a line on top of the same line. So they're going to intersect at every single point because they're the same exact thing. So there's infinitely many solutions to this. So now let's go to number 20. So it says, which of the following expressions is equivalent to this right here? Okay, so let's see. I'm going to start, what's the best course of attack here? I'd probably just start out by doing the fractional exponent thing right here. So I'm going to do x squared and then turn this into y to the 4/5, because if you want to turn this into a fractional exponent, you put a 4, like what it's being raised to on the inside of the radical, as the numerator, and the type of radical becomes your denominator. And then that's going to be to the 3rd power, and then x to the -6. So now let me see, I could just do power to a power rule, which just says I can multiply the 3 by each of the powers inside the parentheses. And that's going to give me x to the 6, y to the 12/5 over x to the -6. So remember, quotient rule says that I can simplify x to the 6 over x to the -6 to be x to the 6 minus -6. Minus is plus, so this is going to become x to the 12th, y to the 12/5. And then, so now I can see, okay, it's probably going to be C or D. And then I'm going to say, okay, how can I change y to look like C or D? So 5 goes into 12. That's going to be 2 times, 2 whole times, and then there's 2/5 left. So like this is technically saying the same thing as y to the 2 2/5, which if you think about another way to write that, you could say that that's y to the 2nd power times y to the 2/5 power. And you would just add up the exponents to get 2 to the 2/5 as your power. So let's think, I could rewrite that in that format, and I could say that that's x to the 12th times y to the 2nd times y to the 2/5, and then I can turn this into like something with a radical involved by kind of reverse engineering that first rule I did where I turned it into a fractional exponent. I'm kind of doing the reverse now, where I'm going to say, okay, now I want the radical back. And I'm going to copy over everything else. So in order to determine what kind of radical it is, I look at the denominator. So it's a fifth root because the bottom is a 5. So I have to write that little 5 on the outside there. And then it's going to be y raised to the power on the top with the numerator. So it would look like this. So then that's going to be answer choice C. Let me see, is that it for this one? Yeah, so that's it for this one. What quiz was that? Was that quiz 7? Yeah, it's quiz 7. Okay, so let me see. Let's go to quiz 8 real quick. Let me see what page it's on. Okay, 278. Okay, thank you guys for the likes. So now we're going to do quiz 8. Again, I'm posting this on YouTube later, so for people who have access to this document already, for the best results, do the problems on your own first, then attempt corrections on your own, and for anything that you just are stuck on, watch the video explanations to help you out. So let's go and do number 1. What type of function, let me make it not blurry, what type of function is graphed below? So linear means it's a straight line, which we don't have here, so automatically I can cross out the stuff that says linear. So it has to be exponential. Now I have to determine is it increasing or decreasing, so I have to read it from left to right. When I go from left to right, it's going up, so it's increasing exponential, A. So now let's go to, let me try to make this a little less blurry. There we go. Now let's go to number 2. So we want to know what's the value of x minus 123 all raised to the third power. So I have to figure out what x is essentially. So right away, I'm probably going to have to use that rule that says that inside of a triangle, like all the angles add up to 180, because I see there's like a nice little triangle right here. I see vertical angles right here with the 72. So vertical angles are equivalent, so that has to be 72 as well. And then this, these are supplementary angles. They add up to a straight line, so they add up to 180. So that means that this has to be 60, because 60 plus 120 is, let me make that a little bit clearer. So 60 plus 120 is 180. And then another way that I could write this angle right here is, well, x plus this angle, this mystery angle right there, are supplementary. So they have to add up to 180. So another way to write that mystery angle right there is to say it's equal to 180 minus x. So that's what I'm going to do. And then now I'm going to add up all of these interior angles inside of the triangle and say that they add up to 180 because they're inside of a triangle. So 60 plus 72 plus 180 minus x is equal to 180. So then I could say, well, the 180s cancel out, so then there's just 0 there, because I could just subtract 180 from each side, and then that becomes 0. And then 60 plus 72 is going to be 132. So 132 minus x is equal to 0. I could just add x to each side to say, okay, 132 is equal to x. So then, to find out the value of this, I just have to plug that in for x. So it's 132 minus 123 cubed. So, oh my god, that is like... I need to write that off to the side, because in my head, that's going to all get jumbled up. So then, let's go over here. That's going to be 9, 0, 0, so just 9 cubed, which is equal to 729. Okay, so then let's now go to number 3. So for number 3 over here, which of the following expressions is equivalent to this right here? So I'm going to, let me see, I'm going to look at the answer choices to help me out. So I'm going to start by simplifying this radical right here. So this is saying that I'm taking the square root of 3 times itself like 7 different times, like 3 times 3 times, like until you have 7 of them multiplied by each other. So if I have 7 of them, I kind of want to like show this visually so that people get what I'm saying. So like if I have 7 of them like this, so that's 1, 2, 3, 4, 5, 6, 7. Remember, if I have a pair of factors, I can take that out when I'm simplifying radicals. So I have 3 pairs of 3s. So I could take out a 3 different times, 1 time for each of the pairs. So 3 times 3 times 3 would be 27. So I could have 27 square root, and then what's left inside is the 3 right there. And then times 3 with the 7th root 3 right there. So it's kind of looking like one of those. So then let's see. That would just be... Oh, well, I could turn these into... Actually, I should have probably kept that as like a 3 to the 3rd power. I'm going to rewrite the 27 as 3 to the 3rd power. Whoops. And then this is going to be 3 to the 1/2 power. And then I'm going to have times 3 to like just the 1st power times 3 to the 1/7 power. And then product rule says that I can just add all the exponents. So I can say that this is equal to 3 to the, well, I'm going to just do 3 to the 4th power times 3 to the 1/2 times 3 to the 1/7. And then that way I have like this kind of isolated nicely. And then I can say, okay, I'm going to add up 1/2 plus 1/7 right there. But I have to have a common denominator, so I'm going to multiply this by 7 on top and bottom, and by 2 on top and bottom right there. So then that's going to be 7 over 14 plus 2 over 14, which is just going to equal 9/14. So this is 3 to the 9/14. So 3 to the 4th times 3 to the 9/14. Now, 3 to the 4th is going to be equal to 81, so I know it would be 81 times 3 to the 9/4. If I turn that into like a radical format, it would be 3 to the 9th, and then the type of root it is on the bottom with that denominator, so 14. So then that's just going to be answer choice C right there. Okay. Oh, wait, not C, sorry. That's a 27. I meant A. So 81. Okay, so then let's go to number 4. So it says, given the expression right there is equivalent to that, where k is a constant and x is a positive rational number, which of the following is the value of k? Okay. So that has to equal that basically. So let's set that up. Let's say 27 over 9x plus 54 has to equal 3 over x plus k. So then we can just cross multiply. And wait, which of the following is the value of k? Hold on, let me think about this for a second just so I can make sure I'm doing it the most rational way possible and not doing extra steps that aren't needed. Yeah, that's how I would do it. Cross multiply 27x plus 27k, because I'm multiplying 27 times that, equals, and then I'm going to do 3 times this whole thing. So 3 times 9x is going to be 27x, and then 3 times 54, that's going to be, so 162. And then I'm going to say, okay, well, I can subtract 27x, and it's going to cancel it out on both sides. And then I'm left with 27k is equal to 162. Then I'm going to divide each side by 27. So I have 162 divided by 27. So that's going to go in 27 times 6, I think, is 162. But let's just check that. Yeah. So then it goes in evenly 6 times, so it's going to be that k is equal to 6. So answer choice C. Whoops. Okay, let me just erase all that out of the way. Wait, did I skip one? Oh yeah, there's one down here. Okay, so now let's do number 5. So number 5 says we have this quadratic, and we want to find the sum of solutions. So we want to find negative b over a, because that's the formula for sum of solutions. Just get into the habit of setting your quadratic equal to 0, even though it doesn't really matter for this one. I just like students to get in that habit, so that's why I'm subtracting 1 to make it equal 0. Now I'm going to determine what a, b, and c are. So a has to be negative 3, and b is the number being multiplied by x, so it's going to be 1. So now I can plug that in right over here, and I can say that's negative 1 over, and then a is negative 3. So that's going to be positive 1/3 as my answer. And let's erase that. And now we can go to number 6 right here. Someone just said something that's a very common misconception, so I'm going to clear that up. They said, I thought it was negative b over 2a. That's if you're finding the x value of the minimum or maximum, or like the vertex, also known as like h, or the x min, x max, also referred to as the axis of symmetry. So that's a different question entirely. Sum of solutions is the one that's negative b over a. If they were asking you to find like the x value of the vertex, or the x value that they have like a min or max at, then that would be the negative b over 2a one. So let's go to, no problem. So let's go to number 6 now. So we have the system of equations right here, and we want to find the solution. So let me see. I'm going to multiply this whole thing by 3 to just get rid of that denominator, so I don't have to work. Oh my god, that was a terrible 3. So I don't have to work with fractions. So then that's going to be 3y is equal to negative, is that going to even help me that much? Well, let's see, negative 1 minus 5x, because the 3 is canceling out on bottom. And then, yeah, that's kind of helpful, I guess. So then I could substitute in 3 minus x for y, because I know that y equals the same thing as 3 minus x based off of that first equation. So instead of y right here, I'm going to write 3 minus x. So it's going to be 3 times 3 minus x is equal to negative 1 minus 5x. Now I'm going to do distributive property, distribute that 3 to each of the terms inside of the parentheses. So then 3 times 3 is going to be equaling 9. 3 times negative x is negative 3x. And then it's just all equal to the same thing on the right-hand side. So now I'm going to add, I'm going to just add 5x. You could also add 3x if you want, but I'm going to add 5x to each side. So then when I do that, I'm going to get 9 plus 2x over here is equal to negative 1, because it cancels out on this side. Now I'm going to subtract 9 from each side. That's going to give me 2x is equal to negative 10. And then divide by 2 on each side, and I'm going to get that x is equal to negative 5. So I know the x value for the solution has to be negative 5. The only option it gives me with that is a. Now, if they had 2 options with negative 5 as your x value, all you would need to do is plug in negative 5 for x into one of these equations, doesn't matter which one, and then solve for y. Like if we plug in negative 5 for the first one, it would be 3 minus negative 5, minus and minus is plus, so 3 plus 5 is 8. So that's how you get the y. So let me just now go to number 7. So for number 7, we have this equation right here, and we want to find the value of k, and then round to the nearest hundredth. So I'm going to do distributive property first, right over here. So I'm going to say 3.6 times k is 3.6k, and then I'm going to have, actually, hold on. Let me do something else. That's going to make this a whole lot less annoying. I'm going to multiply this entire thing by 10. That way I can get rid of the decimal. So like if I multiply by 10 on the left hand side, it's just going to turn into 36 instead, times k plus 7. And then on the right hand side, if I multiply that whole thing by 10, it's going to be 70k plus 36. So now I'm going to do distributive property here. I don't have to deal with like multiplying with decimals. So it's going to be 36k plus 36 times 7 is going to be, carry the 4, 21 plus that is 25. so 252, and that's going to equal 70K plus 36. So then I'm going to subtract 36K on each side, so that's going to leave me with 252 is equal to, that's going to be 34K, oopsies, plus 36. Then I'm going to subtract 36 from each side, and when I do that, I'm not going to do that in my head right now. That turns into a 4, that's 6. Wait, that's a 4, yeah. So then that's going to be 1. So that's 6, 1, 2, 216. So I'm going to have 216 is equal to 34K. So then I have to divide each side by 34. So it's going to be 216 divided by 34. I have access to a calculator because this is the digital SAT. So 216 divided by 34 is 6.3529, yada, 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 yada. So I'm going to just write that out, 6.3529, yada, yada, yada. And we're supposed to round to the nearest hundredth. This is the hundredth place right here where the 5 is. So I look at my neighbor, which is a 2, so that means I just keep it as a 5. So it should be 6.35 as my answer. So let me go to number 8. So for number 8, we have these box plots right here. And it's one of these, like, which of these are true Roman inequality Roman numeral symbols, not Roman inequality, Roman numeral symbol problems, which it looks like they've taken these off of the digital SAT, but I couldn't confirm it. And plus I felt like it made the problem more challenging. So it's like better to have something harder than easier. So I kept it like this, but just so you know. Which of these is true? So let's see. Dataset A's maximum is lesser than dataset B's maximum. So the maximum is going to be like on the right-hand side where the tail ends. So for dataset A, this is the maximum right here. And for dataset B, this is the maximum right here. So dataset A's maximum is lesser than dataset B's maximum. So that is true. Now let's go to 2. Dataset B's minimum. So the minimum is the opposite, like it's where it ends on this side. So dataset B's minimum is lesser than dataset A's minimum, and it is lesser than dataset A's minimum, so that tracks. And then we have dataset B's median, which the median is like the little line inside the box. So like this guy right here for B and this guy right here for A. So dataset B's median is lesser than dataset A's median. Yes, that is true. So it would be 1, 2, and 3. So let's go to the next one. So number 9 says we have this equation. Alexa is running a small tech startup and needs to budget for additional computer servers. The equation above is used to determine the total power supply Y in kilowatts required to run X servers in her server room. Based on the equation, which of the following is not true? So we want what's not gonna work, what's not true. So this is a linear equation. So I'm going to isolate y so that it's more in like the y equals mx plus b format, so I can easily answer questions about the characteristics of this line. Thank you for sharing the live. So I'm going to add 2x to each side because I'm trying to get y by itself. So I'm going to say that 3y is equal to 21 plus 2x. Divide by 3 to get y completely by itself. So 21 divided by 3 is 7. And then that's going to be 2/3 times x right there. So 3 more servers require 2 more kilowatts of power. So pay attention to your units. So like kilowatts of power is going to be y. And the number of servers that they're running is going to be x. So if we're thinking of slope as the change in y over the change in x, the units that should be changing should be the kilowatts over the servers. So if we're saying 3 more servers require 2 more kilowatts of power, then that would mean that the slope has to match up with 3 being with the servers and then 2 being with the kilowatts of power. So 2/3, that works. So A works, meaning that it actually doesn't work for the purposes of the problem because we want something that's false, that's not true. And then let's go to the next one. B says one more server requires 2/3 more kilowatts of power. So let's see if that works with the unit. So one goes with the server, one more server requires 2/3 more kilowatts of power. So 2/3 over 1 just simplifies to 2/3, which is the correct slope. So that works, meaning it doesn't work for the problem. And then let's go and look at the next one. C says 2 additional servers, so 2 goes with the servers, require 3 more kilowatts of power. So 3 is with kilowatts, 2 is with servers. That would be 3/2, not 2/3. So that does not work. That's not true. So the answer would have to be C. Let me just erase this. And, oh yeah, we're on this one, number 10. So for number 10, it says rectangle A has a length of 3 centimeters and a width of 7 centimeters. What is the perimeter of rectangle A? So if we draw this out, it's going to be 3, 3. Technically, I should have been, I should have switched this up, but it doesn't really matter. I'm just realizing now that as I'm reading the problem, that the length should be 7 and the width should be 3, but same thing. What is the perimeter of rectangle A? So this is what it looks like. So then I'm going to add up all the side lengths to get the perimeter. So 7 plus 7 is 14. 3 plus 3 is 6. So 14 plus 6 is 20. Let me just write that as like a little note so I can edit this later. And someone asked a question I'll get to in 1 second. What is this? This is quiz number 8. That's number 10, length/width. Okay. What technology are you using? This is one of the Samsung tablets. I think it's the Samsung like 7S tablet or something like that. I got it off of Amazon, and then I'm using like the app, one of the apps it comes with, which is like Notepad or Note Shelf or something like that. Note something. So yeah, I think that's what it is. Tab S7. No problem. So then let's go to number 11 now. So for number 11, we're going to assume that W, P, and Z are positive integers. Which of the following expressions is equivalent to this? So I'm probably going to have to just use, not quotient rule, product rule, which says that if we're multiplying with like bases, we have to add the exponents. So I'm going to look at the W's first. So W to the -1 times W to the second power. If I add those exponents and keep the like base, it would be -1 plus 2, which is just going to be +1, which I don't write that, like we don't write to the first power, so I'm just going to leave it like that as W. Now I'm going to do the same thing, but with P. So P to the second power times P to the 7th power, I would add the exponents to get 9. And then with the Z's, I'm going to do the same thing where I keep the like base, and technically there's, even though there's nothing written with the Z, it's an implied 1, so you have to be careful with that. So I'm going to say that it's 3 plus 1 for the exponent, so that's going to be to the 4th. So then it's going to be answer choice C. Someone asked why not. I'm assuming you're saying why not for like why we don't write the exponent of 1. It's just, I don't know the exact reasoning of like who came up with that rule, but it's just like a thing we do in math where technically like we don't like writing 1 out in front as a coefficient or as an exponent, so we just like imply that it's there basically. There's a lot of stupid stuff that happens in math. Okay, so let's go to number 12. The table below, if it was a negative, do we put it as the denominator? If it's a negative, oh, you mean like if you have, like I'm gonna do it with a different variable. I'm assuming you're asking like if it's x to the -1, do you put like a 1 in the denominator like this? You could as like a step in your thinking process, but at the very end, your answer should be this, 1 over x. I think that's what you're asking. Okay, so No problem. So let's go to the table below. Relates to 3 private airplanes purchased by a private airline that caters to celebrity clients. Which of the following linear functions expresses the relationship between the airline's monthly income in dollars and the airplane's purchase price in thousands of dollars? Assume D is the purchase price in thousands of dollars. And right away, just a note. And they've been loving to do this. They do this sometimes on the SAT, but it's been like a bigger thing, I would say, on the ACT, where like little things with the units are like put in to trip you up. Like here it says that the purchase price is in thousands of dollars for our equation that we're going to do, but here it says dollars, so you have to be careful. And MD is the monthly income. Okay. And monthly income is supposed to be in dollars, as stated right there. So we're going to see, okay, which of these matches the situation that they've given us, basically. So all of these are, like, there's no exponentials or anything, so we're thinking about it, and I think they even said, or I wrote this, that it's a linear relationship, yeah. So you have to think in terms of y equals mx plus b. It's just that instead of y, you're writing m of d instead, but it means pretty much the same thing. So we have to figure out like what the slope is and what the y-intercept is. Or technically you could also just like plug in values to see like what's correct if you want. But that's not as efficient. So if this is going to be the monthly income in dollars, so this has to be dollars. And then this is going to be, it said, for the equation that the x, or in this case d, is going to be in thousands of dollars. So this is in thousands of dollars. Okay, so that means we're going to do, if we're thinking about slope, it's the change in y in dollars over the change in x, which is in thousands of dollars. Okay. So, let's go and see how it changes. So, to get from 20 to, what do you call it, 12,000, it's going to be going down by 8,000. $8,000. I should be very careful with the units. And then from here to go from 2,500,000 to 1,500,000, and remember, this is in dollars, it's going to be going down by $1 million. But then remember, we have to think about it in terms of thousands of dollars. So like if it's going down by $1 million, but we're supposed to be thinking about it in like a certain thousand, in thousands of dollars, we have to divide by 1,000 basically. So 1, 1, 1, I'm canceling out 1 0 on top for every 1 0 on bottom. So then it's going to be negative 1,000 thousands of dollars. So then that's going to be negative 8,000 over negative 1,000 for our slope. Negative over negative is positive. We can cancel out 1 0 on top for every 1 0 on the bottom. So then we're going to get a slope of 8. So the slope should be 8, so that should be what's being multiplied by what's acting as x, which in this case is d, so it should be c. Right there. So that's the only one that has 8 times d. Isn't it minus 5,000? No, because it's, look, it's minus 1 million, and then you have to divide the million by 1,000. To get from 2.5 million to 1.5 million, it goes down a million. Okay, so let's erase that. Oops. No problem. So now, oh, there's another one down here. Okay, so now we're at this one, number 13. So we have this equation. If the equation given above has no real solutions, when k is greater than b, then what must be the least possible value of b? This is one that I saw also showing up a lot on the digital like study guide stuff. Then what must be the least possible value of b? Okay, assume that k is a constant. Okay, So this is a quadratic, so let's get the quadratic equal to 0, because remember we're talking about how many solutions, we're thinking of discriminant formula, this guy right here. And if it has no real solutions, that means that the discriminant, when we plug in what a, b, and c is, has to be negative or less than 0. But before we could determine what a, b, and c are, we have to set this whole thing equal to 0 by subtracting 12x from each side. So then it's going to be 3x squared minus 12x plus k equals 0. So a is going to be 3, b is going to be negative 12, and c is going to be k. So now I'm going to plug that in for like a, b, and c where they are in the discriminant formula and set it to be less than 0. So b is negative 12, so I have negative 12 squared minus 4 times a is going to be 3, and then c is going to be k, and that's going to be less than 0. Negative 12 squared is going to be 144, and then minus 4 times 3 is going to be minus 12, and then times k, so minus 12k, is less than 0. So now I'm going to add 12k to each side, so then it's going to be 144 is less than 12k, and then we're going to divide by 12 on each side, so then it's going to be that k has to be greater than 12. Some people like to write it the other way around, like you can, it means the same thing, like k is greater than 12, like you could write it like this if you see it better that way. Same exact thing, because the alligator mouth part is just pointing to the k, or is open to the k, I should say. So k has to be greater than 12, and we want to, wait, if k has no real solutions when k is greater than b, then what is the least possible value of b? So then the least possible value b would just be 12. So yeah, b is equal to 12 right there. Can you type it? Hold on, there's a couple of questions. I'll get to everyone's questions. Can you type this into a calculator? You see how there's like in general, quadratics, yes, you could like graph it a quadratic on a calculator, but with this one you have two unknowns. Like it's not just that you have like x as your like typical unknown, you have this extra k unknown value. So no, it's not going to help you to just like do that. Can you do rate problems, please? I will be doing the rates chapter at some point this week, maybe tomorrow or the next day. So I'll be uploading it onto my YouTube channel, but I'm trying to get the quizzes done today. What tips do you recommend for becoming better at math? Best thing to do for practice is just doing problems over and over again and attempting corrections on your own. Like, the worst thing you can do is like get it wrong, look at the answer key and be like, oh, I remember, I think I could do that, and then not actually do it. Like, you want to actually try correcting it on your own first, instead of just like look at the key and be like, oh yeah, that makes sense, because typically you can't recreate that same correct answer, is what I've found with most students. So that's what I would recommend, like doing problems and corrections over and over again. So let's now go to number 14 here. Are natural logs and logs going to be on the SAT? No. So logs are just the ACT. So let's go to number 14. The table below shows, and thanks for the likes, guys. The table below shows the frequencies for each value that correspond to dataset G and dataset H. And so here's the table. Which of the following correctly compares dataset G and dataset H? So let's see. So it's mean and median that each of these are talking about. Okay. So when it says frequency, like that means how many times that value is going to occur in your list of data. So like when it says 4 is the frequency for that corresponds with dataset G that corresponds to the value of 4, it means that like 4 is written 4 different times for dataset G. So I kind of like, you're obviously not going to do this on test day, but just so like people can visualize it, dataset G is going to be 4 written down 4 different times. And then this means if we have 2 as the frequency and 8 as the value, that means 8 is going to be written down 2 different times. But I'm going to write that after I do the 7, because I'm going to put it in order to help me with the median. So 3 is corresponding to 7, so that means I have to write 7 3 different times in my list. Now I'm going to do 8, so 8 shows up 2 different times, so it's going to be 8, 8. And then for the 10 value, it's going to show up 5 different times, so it's going to be 10, 10, 10, 10, 10. And then, oh, I'm going to run out of room. Okay. And then, what's the best way to do this? And then for H, I guess I'll just write over it. I don't know. For H, it's saying that we have 4 written down 5 different times. So it's going to be 4, 4, 4, 4, 4. And then let's go to the 7. 7's written down 4 different times. So 7, 7, 7, 7. And then with the 8, it's written down once. And then with the 10, it's written down 3 different times, is what this all means, basically. So if we're trying to look at the median, because that's the easiest thing to find first, there's going to be, let's see, that's just going to be 13 there. And then there's, is that a 5? 8 plus 6, so that's 14 there and 13 there. Okay, so they have different amounts in each of the lists. So there's going to be 13 values in the H list. So that's going to be easy to find the median because it's just going to be like the one that's smack in the middle. You don't have to take like the average of the 2 in the middle, the 2 values that end up being in the middle. So here the median is going to end up being 7. So median, H's median is going to be 7. And then if you look at G's median, so then there's going to be 6 on that side and 6 on that side. So, you know, like the 2 middle are going to be 7 and 8. So halfway in between that, if you take the average, it's going to be 7.5. So 7.5 is the median right there. So now to find the mean, you're basically just going to add up like all the numbers in your list and divide by how many there are. Like I've mentioned, I think in like the previous quiz or the one before that, the easiest way to go about that is to just multiply, like instead of doing 4 plus 4 plus 4 plus 4 plus 4, like write it as 4 times 5 because there's 5 groups of 4 in your calculator. And then like do the same thing for like the 7s, so on and so forth. So let me just do that really quick. Well, actually, sorry, I'm like all over the place right now. So actually what you could do also is like eliminate answers based off of just finding the medians. And then if you need to find mean, you can go and do that to kind of like save yourself time. So let's compare the medians first. So the median for G is going to be higher than the median for H. So let's see like which of these says that. Median G is greater. So the mean and median are less than the mean and median for dataset H. So no, G is not less, so it can't be that one. Both the median and mean of dataset G are greater than the mean and median of dataset H. So the median is greater, so that could be it. The mean of dataset G is greater than the mean of dataset H. We don't know that yet, but the medians are equal. The medians are not equal, so it can't be that one. And then we have the mean of dataset G is greater. Okay, we don't know that yet. The median of dataset G is going to be less than the median of dataset H, so it can't be that one. So it just has to be B. You don't even have to figure out the means yet. So that actually saves you a whole bunch of time instead of having to like do the whole like figuring out the mean portion. But you could technically do that just to verify if you want to. Have you taken physics by any chance? Yes, I hate physics. It's the one thing that I say like I will never be able to teach myself. I hate it with a burning passion. So number 15 is going to be this equation right here. For the equation shown above, A, B, and C are positive integers. Which of the following equations expresses A in terms of B and C? So I just have to isolate A by dividing by 4 everywhere. So then I'm going to get A is equal to 13 fourths times C plus B over 4. Oh, it looks like that's not how it was written. So just based off of the answer choice, like that is technically correct. It's just, it looks like it was written a different way. So I'm going to just divide the whole thing by 4. So then I'm going to say that it's going to be 13C plus B all of that divided by 4 instead of separating it out. So then that's just going to be answer choice C right there.